Okay. Okay, so today we are going to be handling loops. We're going to be handling loops. We'll define what loops are. We'll talk about the types of loops and then some examples. Can you hear me? Can you hear me?
Will the class be recorded?
We can't hear you.
Of course, it is. It is recorded. Yes, so can you hear me better?
Yeah.
Okay, just try. Okay, so we are talking about loops today, and somehow I believe that 1 or 2 persons should know what loops are kind of. You should know what loops are generally. Like, well, you may not, but somehow those that maybe have come across coding in one way or the other may have an idea of what loops are. So loops generally are repeating structures in programming. Whatever it is, a block or a code or a line of code that repeats again and again, depending on some kind of parameters. Okay, so that's what we're going to be talking about today. And my name is, as you can see, my name is Kachi. You can call me Kachi. So that's my name. Give me a moment. Let me accept people into the meeting. All right, so you say the loop is a programming function that iterates a statement or a condition based on specified boundaries. I'll just read through this and I'll say 1 or 2 things. A specific statement or a group of instructions. Please, can you hear me?
Yes.
All right, so just call my attention somehow. If you cannot hear me, I'm on full screen mode so that you can see the presentation properly. So I won't see everything. So just call my attention if you can't hear me. So all right, so a specific statement, a group of instructions is continuously executed until a specific loop body or boundary condition is reached. The result of the entire loop body's first operation cycle serves as the next repetition starting point. A loop is divided into 2 parts: loop statement and then the loop body. The loop statement defines the time limit to be true for the continuous loop that is contingent on the attached conditional statement. Loop body. This whole statement, code or instruction, it is executed with each loop cycle. So you don't need to bother yourself on all these stories. The longer and short thing is that a loop, excuse me, let me try something out so that I want to see if I can, just a moment. Can you still see my screen?
Yes.
Is it clear? Are you struggling to see it?
No.
That's your screen.
Yes, sir.
You can see it, right?
Yes.
Yes.
All right, good. I'm more comfortable like this. So Please try and mute yourselves if you are not saying anything. Okay, so a loop, long and short, is a structure in programming or encoding that just repeats itself over and over again. And there are many things that, in our everyday life that we even do in loops. Many things we do in everyday life. For instance, you brush your teeth every morning, you have your bath, you eat. If you don't eat, you will definitely get tired, you'll collapse and die one day. You get that kind of thing. So there are many things that we do by loop and we don't know. We don't know, but we apply many of these principles on a daily basis. And so, it says that a loop is divided into two parts. A loop is divided into two parts: the state and the body. The loop statement is like the condition for which the loop continues. So it's the condition for which the loop is maintained. Maybe if I say, as long as a
Hello?
particular value is less than 10. Can you hear me? Can you hear me?
Yes, I can hear you.
Yes.
All right, good. So we can say maybe as long as x is less than 10, I should print Merry Christmas. So as long as x is less than 10, I should print Merry Christmas. So that is in the structure, the statement, the loop statement is as long as x is less than 10. Now the loop body is now the instruction that the computer should perform as long as x is less than 10. Do you get what I'm trying to say? So I don't have any particular example. Okay, I can give you a straight example immediately. So can you see this particular slide? I'm on a minimized view, so you may not see everything on the screen. Can you see my slide now?
Yes.
Respond if you are seeing it, so
Yes.
that we can continue. All right, so here it says list. I don't know, people have not done anything like list. Okay, you know what will happen? Let me try and do an example very quickly on my just give me a moment. Okay, so let me share another screen for you. Okay, so can you see my screen currently? For instance,
Yes, you can.
Sorry, can you zoom
okay,
in? Can you zoom in?
can you see now?
I think you can zoom in by yourself.
So I can say why x is less than maybe 10. I should print Merry Christmas. I know that Christmas is over, but I'm just using this as an example. So I should print Merry Christmas. Why x is less than 10? Then I will now say, this is a very simple example of a loop. So if I run it now, if you can see this other side of the screen, you saw where Merry Christmas came out like 1, 2, 3, 4, 5 times. Do you understand? I hope you are seeing my screen.
Yes, yeah. It's just a bit
All right, good.
tiny.
So, and just focus on the code part. Just focus on the code part. I've tried to zoom in and zoom in. So this part that I highlighted now is the loop statement according to that slide. Then this other part is the loop body. This is a very simple loop, and it gave me output. This is the output here. Do you understand? It gave me, I cannot zoom in this side, so it gave me the output as you're seeing, and that's how loops work. So there are different types of loops. There are different types of loops and different examples. It's used a lot in programming. All right, so that's on that. Let's get back to the slide. All right, so that's on for loops. Okay, so I haven't done any example in for loops. Let me do an example in for loops. Just, you may not get everything that we describe in the for loop, but what my interest or what your interest should be is on the for, and then how it's put into the function, or how it's put into the loop structure. So so I'll get back to my code window. Give me a moment. All right, so I'll get back to my code window and I'll grade this out and then do an example with a for loop. So I can say for I in range 1 to 10, maybe I should print Obi is a boy, something like that. So you know that from this code now, you are going to have Obi is a boy appearing 10 times. Now, this is how a for loop is used. And that's why if you look at that particular slide that we looked at, they gave us a list and they said for item in list. Now, this item can be anything. It can be for I in list, print I. So it could also be the same thing that I did in that particular that particular example on my code window. So sorry. So I said for I in range 1 to 10, I can as well have said print I. I need to print I for me to print I to range from 1 to 9, and the code will still be very valid. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, you cannot see my console very well. I cannot zoom it in. I cannot zoom it in right now. So you just have to manage. You can zoom in your screen or something like that. But my interest for you is this place. This is the condition. This is the condition. That's the loop statement, and this is the loop block. All right. So let's get back to the slide and push forward. All right. So in the for loops, okay, you have another example here. It says another example is given below. It iterates over the letters in a particular string. That's like in a particular word, for instance, Python. So it says for letter, this is the name Python. It's a string, and from the past knowledge you've had, you know that anything that has been put in apostrophe, or that is has put in quotation mark, is a string. So it says for letter in name, that's for letter in Python, print whatever that letter is, and you can try it out yourself. So let me give people 5 minutes. Let me give people 2 minutes to try that out yourselves and see the result is going to give you. So let's quickly try that out. Is there anybody that has tried it out? See my code. Sorry, I stopped sharing my screen. Yeah, see the screen here so that you can see what we're talking about. Yeah, this is what I want you to try out. So I'm going to italicize it so that you can see it. I'm bolding it as well. So this is what I want you to try out. All right, so Try that out. Once you've done it, tell me and then let me know the result you got. If you had an error, also let me know if you had an error. I hope you're doing it. This is what I want you to do. I'm highlighting it already. So I want you to try that out. It's boldened, it's in italics. Try it out and let us know. I hope there are people viewing this lecture with their laptops.
Excuse me, please.
Yes.
Okay, so for the stuff you said we should try out, when we are putting
Yeah.
print letter, what letter are we supposed to
Yeah.
print?
And
Like, I
did
don't
you?
get.
Okay. Did you write the previous line for letter in name? Did you write for letter in name?
Yes.
And then with your colon, then after the colon, write print letter. Sorry. So have you done that? Try and run the code and check out what you get.
I ran the code already.
Let's see.
So what letter was printed?
Python in different lines.
Okay.
Python.
Okay, so all those individual letters were printed out, right?
Yes.
All right, good. So that's what that code means. So that's what that code implies. Hey, it means that you can iterate over each of the letters in that word Python. You can iterate over it, so you can take it one by one by one. So that's what you are doing there actually. So a string is an iterable. That's like you can iterate. What it means to iterate is like to go over a particular thing in its stages. So it's like climbing a step. So you're not getting from step 1 to step 10 at the same time. You take from step 1 to step 2 to step 3 to step 4. So in strings, Python, this word is a string. So you should know from previous lectures, hey, you should know what a string is. So a string is an iterable. Another thing that is an iterable is a list. Is a list. A list is an iterable. Give me a moment. Let me see if I can put a marker. Okay, now see what I've highlighted. Now, a list is a data structure, so it's an iterable. What I've highlighted straight here is an iterable. That's like you are going step by step. You are picking each of the elements in that particular structure. So in the list now, the first thing is 34, the second thing is Johnny, the third thing is 89 point something, the fourth thing is Apple. So all those things are like the different steps in the list. So it's an iterable too. All right, so that's on that. Now, in using, I hope you can still hear me.
I'm feeling fine.
All right, good.
Sound.
We can.
Okay, so in the use of the for loop, you
Good
have
evening.
a
I
break.
just joined the.
Okay, just
Hello.
follow.
Okay. Sorry.
Yes, just follow as
Before we go
forever
ahead,
speak over.
sorry. This is the third class, and then I've been complaining since the very first class that the Slack app is very, very difficult for some of us to make use of, and then the WhatsApp group, I'm not added to it. Like this is the third time I'm talking about it, and then also I dropped my email. Maybe I can get slides, and I don't know. Following the class is easy for me. Yeah, join the Microsoft team, but using the Slack app and then getting the slides, I'm unable to get it for further studies.
Okay, okay. What is your name? Let me see.
Ogunwale or Laleko.
Okay. I think I understand what the issue is. Just drop that's in the chat section, drop your name,
Yeah, the
your
chat
email.
section here, right?
Yes, in
I'll
this
do it.
place, drop your
I should do
mail
it
and your
now, right?
email. Your name and your email. Yes, yeah, do it straight away. All right. So yeah, back to what I was saying. Um, so you use the break statement when you want to stop the loop. For instance, if you come to this, if you come to this particular example I did, let's say this one, I believe you are seeing my screen. Now I can come and say that if I is equal to 7, I should break. Now, what it means is that when I is equal to 7, normally the for loop will continue to run until I is equal to 9. The loop will continue to run until I is equal to 9. But with this statement, what break does is that um, once you put in a break in a loop, that loop will stop even though it has not gotten to its expected end, and even though it has not gotten to where it should get to, that kind of thing. So that's what your break statement actually does in your loops. So you have two of these kind of statements. You have the break and the continue. So break will stop the iteration completely. It will stop the iteration process completely. Now, but you can also use continue. Continue will continue the iteration, but that particular stage will not run. Now, what it means is that if I'm climbing, let's say, okay, let me just use the same example of continue here. So what it means is that when I is equal to 7, if I say continue, it means that the the iteration that should have run after this particular code, this line, this statement, this my continue statement, will not run. It will go straight to the next loop. So it will go to the situation where I is equal to 8. So it's like saying, okay, I'm climbing the stairs. When I get to 7, I should not put my leg on 7. I should just jump 7 and go to 8. So what will happen is that I will go from 6 straight to 8, skipping 7.
Uh,
That's what the
um,
continue statement
hello,
does.
hello.
Yes, yes, yes,
Sorry, the chat
yes,
section you told me to type. I can't access it. It's saying I'm not a, what do you call it, visitor. I'm not sorry, I'm a
yes,
guest.
yes. That's what I just noticed. That's what I just
So I
noticed.
can't.
So, okay, okay. Just at the end of the class, remind me so that I'll put it to mind. I'll commit it to memory.
Okay. But I might not be
Yes.
able to finish I'll be finishing class around 6:30. I'll be offline. So what do we do? That's why I'm asking a request. I do the stuff
Okay.
while the class is on.
I just typed a message. Can you see it?
Set.
Can You said you cannot access the chat section. Do you see the messages that people drop on the chat section? Are you
Yes,
able
yes.
to see their message? Okay, so you're able to see their messages, but you're not able to type
Okay,
your
I'm
own
seeing
message.
something like type a new message or something there.
Good. So try and see if you can type there.
Okay, okay. I
Okay, so
can't seem to. Okay,
okay,
I think
so
I can. But let's continue first.
okay.
I'll find my way around it.
All right. So I've talked about the continue statement. I've talked about the range. Okay, now let me just say something about it. I've used the range, but I haven't talked about it. So the range, the range is used to loop through a set of code. Ehen. See what range actually does. The range statement or the range function is a function that gives you a list or a set of numbers, a set of integers actually in a particular sequence. It just gives you a sequence of numbers. That's just what happens. So let me give you an example of this. For instance, now let me grade this out. All right. So I can say that I should print range 110. Now, if I run it, just give me a moment. Okay, wait. I can say that x is equal to the range of from 1 to 10. And I can decide to print x. So let's see what this code will give us. Okay, it's still the same thing. So, but what range does,
Can't see your um
Please,
VS
we can't
code.
see your screen.
can you see it now?
No,
We can't see the
Can you see
screen.
it
What we're
now?
seeing, we're just seeing the participants.
What of now?
it's just showing the
Just showing the
submit
participants.
screen.
All right. Can you see it now?
Yes.
All right. So what the range does is like range gives you a set of values. It just gives you like a sequence of values that it gives you a sequence of values in a particular order. That's what the range does for you, and that's what the slide is saying here. So it says to loop through a set of code a specified number of times, we can use the range function. The range function returns a sequence of numbers starting from 0 by default. So it's not always it's not always most times it's by 0. For instance, if I say range 10, it will just start from 0. But when you specify a particular starting point for a range, it starts from that starting point. So normally what we specify in a range is like endpoint. What we specify most times is the endpoint, and by that it starts from 0 at default. We don't specify the starting point, but you can specify both the starting point, the ending point, and even the step. Do you understand? So you can specify both the starting point, the ending point, and the step. That's like, for instance, if I want to start from 1 to 10 now, if I want to go from 1 to 10, I can say, okay, I want to go in the normal steps of 1, which is what is here in our slide. You can also say you want to go in steps of 2. So you can say from 1 to 3 to 5 to 7. Like that. So that's the way the range works. And the range is used basically in looping. You can use range to generate a list. You can use range to generate anything, but the main thing is that range is used very often when it comes to looping. Anything that is repetitive. Range just gives you an idea of, okay, how many times are we supposed to go through this? That's what the range does. All right, so see the example that we have in our slide here. Now for x in range 6, print x. Let me just read you. It said, note that range 6 is not the values of 0 to 6, but 0 to 5. Now, the starting value for every range function is 0, unless it's specified. I've mentioned this. I've also talked about the steps. So that's it. That's it. You can look at the slide again, but all of these here that I've already mentioned it. And I forgot to say that the range stops the range every always stops at a number before the specified end. So if I say that the end of a range is 30, the last value is going to give me is 29. So the last value is going to give me is 29. that's that's it. So now we are not talking about decision making in loops. That's if and else and elif, all those kind of things in loops. And I've already used an example when I was when I was talking about the when I was talking about the break and the continue statement. So here you can see that I used a you can say I used an if statement. I said if I is equal to 7, continue. So you can make decisions within loops. You can make decision within loops. That's very important. So you can make decision within loops. Yes. So I think from our previous knowledge of if and else statements, you can make a decision within loops. Maybe I don't know. There are many examples. Maybe on a daily in your normal everyday life. Yes, a simple example of that maybe if maybe in a normal day life of okay, I have my bath every day. I have my bath every day. Now I now say in that loop, if the weather is cold, I use hot water. Do you understand? Or if the weather is hot, I use cold water. So that's already like a decision making in a loop. You are making decision even though it's running within a loop. So maybe on Monday the weather was cold, I use hot water. On Tuesday the weather, all those kind of things. So that's where it applies. That's where it applies, and there are many examples, different applications of this thing where you make decisions in loops. Now, nested loop. A nested loop is a loop inside a loop. The inner loop will be executed one time for each iteration of the outer loop. Now, the other side. Okay, let me see if it's also here. Okay, no, not really. So, the the other side of that statement is that the outer loop cannot finish running or cannot short. How do I put this? You cannot get to the end of the outer loop unless the inner loop has finished. Like the inner loop has finished A to Z. A to Z, that's like for every stage of the outer loop. It means that all the stages of the inner loops have run. Because the thing about loop is that a loop always continues until it has finished running before you go to the next thing in your code. That's the way a nested loop works. And maybe I should just give you a quick sample. I don't know if there's any sample I can quickly jump at right now. So now you can see for I in range maybe 10. You can see um for J in range 10 too. You can see print print J, and then I can say maybe end um okay, let me not separate it. Or should I separate it? Let me separate it. Okay, let me just leave it. So end is equal to uh, yeah. So what did I do? Okay, so I can come here and say print. Let's come here and say print. So let's see what code gives us. Okay. Just give me a moment. Okay, so I don't know if you can see my screen. Can you see my screen very well? Can you can you see my screen?
Yes, yes, you can.
Okay, can you see the result of the line of code I wrote?
Oh,
See this. Can you see it? Is there anybody that can see it? Like even if you zoom your screen or something like that. Yeah. Is there anybody that can see it?
I can see it.
Okay, wait. Let me see if I can. Let me see if I can create a new slide and show you the result of my code. Just give me a moment. Okay, just give me a moment. Can you see the? Can you see my code? Can you see what I put on the screen?
Yes.
Yeah.
All right. All right. Good. So let me do something very quickly. All right. So this is what I put, and then this was my line of code.
Hello. Sorry, excuse me. I don't understand the code.
Yeah, just relax. Let me.
Okay. Sorry. Hello. Before
Yes.
the class, uh, can you please just maybe you should drop your phone number and then we should, that chat thing. It's better we get a slide and then you can drop your phone number. Then we'll just type it now, hold on to it, and get back to you later.
It's okay. It's okay. I'll talk more on that like after the class.
And what
Yes.
I'm
So
saying is, some of us might not be able to finish with the class. Like some of us are
okay.
like 6:30 now. That's the reason why I'm
Okay. Okay. Okay.
doing
Okay.
this.
Okay. Okay.
I could call out your number for him to put down.
Okay. Yeah. So you can reach me on my mail.
Your can you state just give okay. I can see
So
it
that's
now.
my email. Yeah. So you can reach me there. So
She
this
let
is
me, let me type it. Let me type it.
yes. So this was the output I had. I don't think I copied everything in the code, or I don't think it was able to enter. Let me see. Okay, so this was my code. I said for I in range 10 and for J in range I, right? We should print J. Now, this is an example of a nested loop. Now, what I'm trying to say is that for I in range 10, it means that I assumes the values of 0, 1, 2, 3, 4 up till 9. Means that I will show up 9 times. That's one, two. That's you. If you look at the number of rows, you have 9 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then for J in range I, that's like when I is equal to 0, it means that for J in range 0 in quotes. Do you understand? So you should print J. So it printed 0. Then why I used end here is like in the structure for printing, and the normal thing is that you have what you want to print, then separator and end. That's like what do you want it to end with? Normally, it ends with new line. So but in this case, I don't want it to end with new line. That's why if you want to print 5 things, after I print the first one, the next thing is always on a new line, because it normally by default ends with a new line. But if you change it, when you print the first thing, the next thing can come after the first thing. So that's why I removed the end there. But you don't even need to get this printing part. The part I'm interested in explaining to you is how the two for loops came into a nest, that you're able to get this number structure. So you can see the code. I don't know, I might send the code to you. then you can try and play around it. You can do many other things with it. All right, so that's that. Okay, so you need to move fast. All right, so I've already talked about the while loop. I've talked about the while loop, and the only thing I want to say about the while loop is that the while loop will always continue if the condition is true. So it means that you must have to set something make the condition to change at some particular point. As long as you have got what you are looking for, you must have a setting that will make the condition to change at some particular stage. All right, so that's it. Then there's this code here. Wow, I don't know if the code will look good in your eyes, but try it out. Type it as it is. Type it in and let's see what it's going to give us. Let's type it quickly for those of us that are working with their laptops. So I'm highlighting it, I'm italicizing it so that you can see it very well. So that's the code. So try it out.
We can't see the code, please.
Yeah. Okay, so have we typed it? Have we
Yes.
typed it? Did anybody get? Yes. So did it run?
Yes, it's run.
All right. So and it gave you a temperature in Fahrenheit.
Oh, I thought it's the hello world you asked us to run.
No. See what I want you to run.
Oh, the one in
Can you?
italics. Oh.
Yes. Yes. Type it. Type it. Let me see. 2 minutes. 2 minutes. So that we can go to something else.
We can't see what you asked us to write.
Can't see the screen now. We're unable to see the screen, sir. As far as the code.
We are not seeing the screen. We are not seeing the screen.
I'm just seeing the participants.
We are not seeing the screen. Your screen. Your dark code. I'm not seeing anything.
All right, are we done typing? Okay, we have to move. We have to move. I don't know why it's taking us too long to do this typing. We have to move, so we just go to the next thing and look through it. Now, there's something that I think I need to get back to. Good. I didn't mention it. Okay, so um past statement, the past statement in for loop. Now, I'll just read what is here. Say for loops cannot be empty. But if you for some reason have a for loop content, put in the past statement to avoid getting an error. So that's where I have the example there. It says for x in range 9, pass. So why you're putting that statement there is because if you just type for x in range 9 and you didn't have any block of code or any line range, it's going to return an error. The Python interpreter will return an error for you. So that's why they use pass. That's in very rare cases where you want to create a loop without having a code to run under the loop. All right, so that's it. Okay, so I'll just move over to the break statement. I've talked about the break. I've talked about the else, and I've talked about the continue and pass. Yes. So here's this. Say write a program that allows you to enter a number of test calls. The user indicates that they are done by entering a negative number. Print how many of these calls are A's, that's 90 or above. Also print out the average. So I don't know, can we try this? If we can try this out now, I'll give it to us as an assignment. I'll just add it as our assignment because I know that we have a number of assignments in this slide, about 2 assignments. So I'll just add this one as an extra assignment to you. It's a very simple code. And I don't know. It's a very simple code and I don't know if we'll have the time to look at it, but it's fine. If we're able to get to the end of the slide, we'll come back and do this particular example so that there will be an example from the slide that we'd have done together in class. All right, so the next thing we're looking at is functions. Now I say the function is a block of code which only runs when it is called. You can pass data known as parameters into a function. Excuse me. So you can pass data known as parameters into a function. So a function is only runs when it is called. A function only runs when it is called. Please let's take note of that. A function only runs when it is called. So you define functions and you call functions, and that's what is there in the slide. So In Python, a function is defined by using the def, that's def keyword. So you can, for the example here, have def my function, print this is my function. So anytime you call the function above, what it will just do is that it will print the string, this is my function. So to call a function, use the function name followed by a parenthesis. Now you have my function, okay. That same example, then you have my function. So um, arguments. It says information can be passed into functions as arguments. Now, arguments are specified after the function name inside the parentheses. You can add as many arguments as you want. Just separate them. Just separate them with a comma. All right. So you can add as many arguments as you want. Just separate them with a comma. Now, the following example has a function with one argument f name. That's this example below here now. You know, it says he has a function with one argument f. That's what you are seeing here. Can that person mute himself? Okay, so yes, so it has this particular function here. It has um it has one argument, and I don't know, you might see it later in the slide. Defining functions. Those things that you put inside the bracket, they are called parameters. Yeah, I know that it's somewhere along the slide. When you are now, when you are calling the function and you are putting that information, you call it arguments. So they can be constants, they can be variables, whatever they are. So when they are defining the function, they are parameters. Then when you are calling the function, they are arguments. So both people use them interchangeably and is accepted. One main thing is for the person to understand the context, whether it's the function definition or it's function calling. All right, so this function is here with the parameter f name, and what does the function do? It just prints the f name plus do. So if you call my function with John or my function with Mark, what it does is that it's either John do or Mark do. That's what happens there. So of course, this is what we are talking about: parameter and argument. It's just an issue of perspective. All right. So number of arguments. So by default, a function must be called with the correct number of arguments. There's a function there are two types of functions. That's the functions, the regular functions that must have all the arguments or all the parameters assigned with data. And then there's a kind of there's another kind of function that can accept, we'll still see it in the slide, that can accept a maybe more than the normal number of arguments or something like that. So this by from here you're seeing that the function must be called with the correct number of arguments. Meaning that if your function expects two arguments, you have to call the function with two arguments, nothing more, nothing less. And that's what you have here. So my function with first and last name, and this is what it does. Then you must call it with the first and last name. If you don't do that, you run into an error. All right, so you now have the issue of arbitrary arguments. Like I was saying, it says if you don't know how many arguments that will be passed into your function, add an asterisk before the parameter. Before the parameter name in the function definition. This way you will receive a tuple of arguments. From there you can now deal with it accordingly. So when you have your function with kids, you have asterisk kids, then you now pick a value, a particular value in that tuple that is formed by putting that asterisk. I know that we have not done some of those data structures like tuples, dictionaries, and the rest of that, but with time you will get to it. And this function, this type of function will not be relevant to you. It will not be relevant to you today. Later on, that it will be relevant. All right. So keyword arguments. So there's something that Python also recognizes. Normally, we like to supply our variables in the same order as the parameters. So if I have a function that has like child 1, child 2, child 3, we will normally want to put it in that order: child 1, child 2, child 3. Okay, this here is child 3, child 2, child 1. So we would normally, when we call the function and we put it in order like 1, 2, 3, Python will already assume that the first thing you're putting is for child 1, the second thing you're putting is for child 2, and the third thing you're putting is for child 3, something like that. But once you can assign, like, you can do what you have in this particular next line, say child 1 is equal to Mark, child 2 is equal to L, child 3 is equal to Linus. Once you can do something like that, Python will already know it. You don't need to put it in the arrangement of the parameters already, because it can recognize that, okay, this is for that parameter, this is for that parameter, something like that. So that's it. Then recursion. So Python also accepts function recursion, which is recursion is just like calling a function in a function. So that's what it's saying, a function calling itself. So recursion is a common mathematical and programming concept. For those that did sequence and series, there are recursive sequences, that kind of thing. So it's still that same concept where you have, okay, maybe T2 is equal to T1 plus this, or T3 is equal to T2 plus this, just, or Tn plus 1 is equal to Tn, something like that. So that's the way it runs in recursive functions. And it's used very much. It's used very well in Python programming generally. The truth is that some things that can be done with iteration can be done with recursion. And the other part is that some things that are done with iteration can be done much more easily with recursion. Recursion is a way of easing up some processes or some procedures. It may demand more computational time and all those kind of things than iteration. It may not. It may not. But one thing we are sure of in recursion is that it just makes the process easier. So recursion makes the process easier. So this is a recursive function. Now you have def try recursion k. Now I said if k is greater than 0, result is equal to k plus try recursion k minus 1. So what it has done, it has already called this function inside the function definition. So you have, then you now have print result. You have else result is equal to 0. Then you're supposed to return result at the end of the day. So you're supposed to return the result at the end of the day. You can try this out. Try and plug this into your code, and let's see what we are going to get. Try and plug this in your code, and let's see what you are able to get. Can you still hear me? Hello, can someone still hear me?
Yes.
I hear you.
All right, try and do this. Try and do this. Try and do this. I see my screen. See what I'm waving around. Try and do that thing. Let's see. Try and do this. So try and do this. Let's see what you're going to get. Yeah. Has anybody written the code down? Have you typed the code? Is there somebody with a laptop there?
Yes, we
Yes,
are
I'm still
trying it.
typing it.
We are on it.
Yes. All right, get that done immediately. Let's see what more we can do today. Any issue? Did we get any result?
Yes, I've gotten something. Hello?
Yes. What did you get?
1 3 recursion example results. 1 3 and 50. That it?
Okay. 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 Yes, that's kind of what you're supposed to get. That's kind of what you're
Okay.
supposed to
Okay.
get.
Okay.
Yes. Yes. Yeah.
Could
So
you explain just what?
okay. So let me explain what is here. So it says that let me even start from when a result is zero. When result is zero, it returns the result. That's it will return zero. uh Then when result or what am I saying? When k is equal to zero, the result is zero. Do you understand? Now, when k is greater than zero, the result is k plus the function of k minus one. Do you get? And it prints result. So because the result has not been obtained at this point, let me use my pointer so that you're able to see. Sorry. All right, good. So because k, or because the result has not fully been obtained, because the result has not fully been obtained as because the result has not been fully obtained as a result of this other function that has not been run, the value of this result is not even known yet. The value of the result will not be known until k is equal to 0. Let's say k was initially maybe 4. Now, def
It's
k of
showing
4,
error
when you want to
here.
run, it's showing what?
Syntax
It's
error.
showing what? Maybe you didn't
Syntax
type
error.
something well. Maybe you didn't type something well. I don't know. Maybe you didn't type something well. But let me explain what is here. For those that pay attention, recursion is also something that it's not as if it's hard though, but it's more of like the more you practice it, the more you interact with it, the better you get at it. And I'm going to give us an example. I don't know if there's I'm not sure if I have an assignment on recursion. Okay, there's an assignment on recursion already. Fibonacci series. So Fibonacci series is a good example of recursion, and you should try this out. So I can give you another one that you can try out, which I won't consider as an assignment, but it's like a practice, self-practice. So, but back to what I'm saying. Now, what they are saying is the result has not been obtained, but the result has already been given this value of k plus try of like the function of k minus 1. So let's assume k is 4. Let's use a smaller value. So when k is 4, k is greater than 0. So result is equal to 4 plus the function of k, or the function of k when k is equal to 3. You understand? Now, when k is equal to 3, k is still greater than 0, the result will still be the function of, will still be the sum of k, or that's 3 plus the function of 2. When it's 2, the result will still be k, that's 2 plus the function of 1, that's 2 minus 1. And then when it is 1, it will now be this plus the function of 0. Now, when it is 0, you now have that result is what? Is 0. Do you get what I'm saying? Now, so you have a result is 0, then result is 0, then it prints result. So to print 0, it will print 0 plus 1. It will print like that. I don't know. I can't. If I could like write on my screen now, yeah, I would have shown you step by step how that kind of thing does. But you can do it yourself with paper. Just break it down, step by step. When it is calling another function and is moving into another function, you move to like a new column. Then after that one, you move to the next column, stuff like that. So that's the way it happens. And the more you do it, the better you get used to, the better you get at doing it. The more you get used to it. That's the way it runs. So at the end of the day, it's going to return results. It's going to return results at the end of the day. So when it returns the final result, that's what is actually going to print when you are printing this. So it's like the first result. That's what is going to print out. All right. So you now have like inbuilt functions. There are many inbuilt functions in Python. Many inbuilt functions, both the ones I know and the ones I don't know. We've used range a lot. You use append, you use clear, you use add, you use shuffle, you use sample. There are many of them. You see, it ends with an etc. Many of them math functions and stuff like that. So, and many of those kind of functions. And now you see import math. So this is an example. I don't know if we've talked about importing, but what import does is like you're importing a module. A module is like a class in quotes. It's like a class that is saved in another file. It's like a class of different things. So you have a class of you have functions. I'm trying to remember what it's called. Data attributes and I can't remember the other one. So, but a class contains like different information about a particular area. So you have a class called math class or something like that. But since it's in a different file, it's a module. So you have a math module. You have a math module, and the math module contains all the mathematical whatever you want, whether it's exponential, whether it is square root, whether it is a log, whether it is just many things, sine, cosine, pi, all those kind of things. So they are under the math module. They're under the math module. So when you want to do anything with the math module, you import it. And that's what we did here. So we did import math. Now we are defining a function called square root. So square root, then you have a parameter called n. Now what are you doing? You are printing round of math.square root of n, comma 2. That's like you're getting the square root of n and you're rounding it to 2 decimal places. And you're printing it out. So square root of 15 will just give you, when you call square root of 15, to just print out what the square root of 15 is in 2 decimal places. So that's like the end of, in quote, that's like the end of our lecture today. And you have your assignment, which we are going to drop on the Slack and on the group chat as well. So on the Slack page and on the group chat. And if you have issues, I've dropped my mail and I'll drop it on the chat section so that you can reach out to me via mail so that we'll sort you out. Um, so that is my email. Yes, so you can reach out to me so that we can sort you out, so that you're able to do your assignment, so that you're able to follow projects
You can't
that
access
you're
the
supposed
chat
to
box.
do.
You can't access the chat box.
Yes. You can access the chat. Are you sure? I just
Yes,
dropped it
it says
now.
only available to team members. It says only available
Okay,
to
okay,
team.
okay, okay. All right. I'm still sharing my screen, so I'll just bring out the place where I typed my mail. Okay. Okay, see my mail here so that to be bold enough. Yeah, so that is my email. Can you see it? Can you see my email?
Um, yes, sir. Please, I would love to ask a question.
Okay. Okay, what's your
Um,
question?
in the this one we just work.
Sorry. Yes, I'm listening to you.
So, okay, done results.
The what?
Are you with me? You use
Yes, I'm listening
return
now.
results. Use return results. So I want to know, as in, what is the importance of the return results? Could you just explain what it does in the code?
Sorry, let me look for that code. Yeah. All right. Sorry, I was distracted. Yes. So, return results. That's like at the end, right?
Yes.
So, return results in every. Let me just say this. I didn't mention this while I was talking about functions. Um, many times, but not all times. Return functions are designed or fashioned to return a particular thing. It may return none. It may return a value. It may return it can return any data structure, any data type. You get that kind of thing. So a function can return anything. So what I'm saying is that functions are actually designed to return certain things. They are designed to return certain, even though it's not compulsory. Like I think this might be maybe the first example where a function that is in this slide actually returns a particular thing. So that's it. When I'm calling a function, I can call a function in the sense of, let me see if this thing is still open. I can call a function in the sense of maybe y is equal to um, let's say function. The name of the function is name, and the argument is chica. So functions can be called in this way such that the value of y, or y takes the value of whatever this function name returns. So let's say function name is a function that counts the number of letters in a particular word. It just means that y will take the value of 5. I don't know if you get what I'm saying. So that's where return actually comes in. And you can also print the return value of a function. So back to that, to your question. Sorry. Um, okay, so back to your question. Yes. So for the return result there is like, okay, after a particular stage has been done, do you get? After a particular stage has been done, you are returning the result of that stage. I don't know if you get what I'm saying. You are returning the result of that stage. That's like, let's say k was equal to 4. K was equal to 4. Then, and then let me also say that the the because is a recursive function, initially we didn't have the value of result here until we got to where k was equal to 0 and we had the result being 0 gong, gong, gong. It was now that 0 that you got that was returned to the initial value, the initial mk. You try it out yourself, try and draw it in columns, do you understand, and try and see if the return is not there, do you understand, that return, if it's not there, the value of try of recursion k minus 1 cannot be obtained. You will not get it from anywhere. Do you get the point? So it's what A returns that B takes, and it's what B returns that C takes, and what C returns that D takes. That's why that thing is there. That's part of why that return is there. So if that return is not there, it will not, you will not be able to determine the value of recursion k minus 1. The function recursion k minus 1 will just run something, but it will not return anything to the initial this thing. I wish I could draw my screen so that you will see what I'm saying. You can try it out on paper or something. Let me look for an example. I should have a material that shows this thing. Just give me a moment. Let me see if I'll find it. Can you see my screen?
Yes.
Can you see my
Yes.
screen?
Yes.
All right.
Yes.
All right. Just
Yes.
try and take a look at what we are seeing in this particular code. Now, this is a recursive example on factorial, a very simple recursive example of factorial. Now look at the code here. Okay, no, this is a multiplication code. Now, this is factorial. Now, it says, you know what factorial is now? N factorial is n down, down, down to 1, right? So, the main thing is, this is the main code here. Are you seeing what I highlighted? Can you see my screen? Can you
Yes.
see what I
Yes.
highlighted? Ahead.
Yes.
So that's the main code here. So it says define factorial n. Now, if n is equal to 1, return 1. Sure you get. Else, return n times factorial of n minus 1. Now, why I'm saying that the return is important is when you come to this place now. Now, look at this. You know that initially you have, let's say we are printing factorial of 4. Sure you get. When we come to, I'll have to minimize the screen a little. Now, when we have to, how do I do this for you now? Now, there's what you call scope. There's what you call scope in functions. Like you have scope. That's like, when I was saying that you should draw some things in columns, Like when it calls to a lower function, move it to another column. When it calls to a lower function, move it to another column. So it's like you're moving from one scope to another scope. It's just like abacus now. In abacus, when you are doing evaluation and abacus normally has either 9 or 10 beads or something. When you have 9 plus 1, do you understand? It becomes 10, but you cannot write 10 there. Sure, you get, you move that 10 to another place. Do you understand what I'm saying? Like you move one to the next column. So it's in that same, it's just for you to visualize it that way. So let's see what we're talking about now. We say print fact 4. Now 4 is not equal to 1. What will you do? It will return 4 times what fact 3 is. Now 3 is not equal to 1. It will return what 3 times fact 2 is. Do you understand? 2 is not equal to 1. It will return what 2 times fact 1 is. And then when 1 is equal to 1, it will return 1. So we are going to continue. We are going to go back up now. Now when it returns 1, because of that return, fact 1 has a value here when we are talking about 2 times fact 1. But if we didn't have return, fact 1 will not have a value. It will just be non-type. Like when you have a function that doesn't return anything and you want a value from that function, Python will return and tell you that it is none. So it's like a non-type whatever. So if you don't have that return, that fact 1 will have nothing to give when you're asking for 2 times fact 1. If you also don't have that return in fact 2, it will have nothing to give when you're having 3 times fact 2. Do you understand? Are you seeing the arrow diagram of this particular something? Is anybody seeing it?
Yes, yes.
Good, good. So just you yourself draw it down yourself. Draw it down. It's still the same thing that will happen with your Fibonacci series. It's still the same thing that will happen in your addition or your multiplication. Multiplication is just saying that when a particular, it's just like saying in multiplication, um, you may have like a counter or something. I'm trying to see if I'm getting this right. But with whichever way it is, you know that you are you are multiplication is just like, let's say you are adding like b number of times or something. So when you have multiplying a by b, when you're having multiplying a by b, you keep adding b to a until b drops to 1. Do you understand? You keep adding b, or you keep adding a to a until b drops to, or until b drops to 1. Do you get what I'm trying to say? That's it. You should have the example in this slide too, but it's just like it's just in this kind of steps. You begin from the biggest, like from the most complex situation. You keep going down. You keep going down to what you call the base case. This if n equals to 1, return 1 is what you call the base case. Then the other one, I'm trying to remember what the name is now. It's like the recursive step. I'm trying to remember if the name is here. So you have the recursive step and the base case. So now this is the multiplication one. So you see that you keep adding a to a b times. Do you understand? You keep dropping the value. So see it here. If b equal to 1, return a. Else, that's if b is not equal to 1, return a plus mod of a comma b minus 1. So it will keep doing it until b is equal to 1. When b is now 1, it will return a. Then for the stage of b equal to 2, it also return a. So it will just keep adding a to a until it does it b times. So that's the way the principle of recursion works. It's initially complicated, and it can actually be complicated, but the complexity of recursion makes it possible for you to handle difficult situations in simpler ways than iteration could have ever done for you. So I don't know, have I answered your question?
Uh,
Who
well,
asked
I
that
got some
question?
things. I'm the one.
Yeah.
I'm the one.
Yes,
I
yes,
got
yes.
I got some things, but I've not really gotten everything. Thank you so much.
Yes, yes.
I,
There are some things that time will not permit to say what I can do since you have my mail, or if you're on the Slack Python
Sorry,
cohort in
excuse
the
me.
Slack. Yes.
Yeah.
Okay.
Okay. Now, in this example from this your screen, now if we are starting,
Yes.
if we are doing the try recursion of 6, but on the code I ran, the highest
Yes.
value was 15, and I don't
Yeah.
get that. I was expecting 21.
Okay. Let me see. Hmm. Did you put? Did you type it the way it was here?
Yes, I did. The highest value I got
Okay.
was
So
15.
was 15.
Yes,
Why do you think the highest value you would have got should have been 21? Why do you think it should have been 21?
because I think it's supposed to be, I don't know, if we are going from 1, it will be 1 plus 0, okay, then 2 plus 1, then 3 plus 3, okay, then 4 plus 6, then 5 plus 10, and then 6 plus 15. That's what I was
Oh
expecting.
wait. When is 0?
No,
When is 0, it gives you 0, right? When it's 0,
Yes,
you have 0. Then when it's 1, you have 1 plus
1.
0, right?
Yes,
When it's 2, you have 2 plus 1, right?
yes,
Right? That
yes,
is
yes, right.
3, Abi.
Yes,
Uh, when it's 3, you have what? Um, you have
3
3
plus
plus
3,
what? What did we get before? 6,
2
Abi?
plus 1, 3. Yeah, that's 6.
Yes, that's 6. When it's 4, mm-hmm.
Yes, 4 plus
When
6.
it's 4, we have what? We have 4 plus 6, 10. Abi? When it's 5,
Yes,
you have what? 5 plus 10,
10.
15.
Yes,
Right? Then
yes,
when it's
right.
6, you have what?
6 plus 15.
6 plus 15.
Yes.
And why is there? So you did not get you did not get 6 plus
I
15
didn't
there.
I didn't get up to 21. It ended at 15.
And then there should be something. There should be a reason why it ended at 15. Look at where your print is.
Oh, okay, thank you. It was a problem with the. Sorry for the unnecessary.
All right.
Yeah.
All right.
Thank you.
All right. All right. All right. So any more questions so that we can call it a day? Yes, yes. Any more questions so that we can call it a day? Okay, so that's your assignment. Um, Fibonacci series is a very simple one. Google it anywhere you want to Google it. Just it is simple. It's been a long time since I also did a Fibonacci series with recursion, but it's doable. It's doable. Just study the pattern and see what you can make out of it. Then assignment 2, a password validator. It says write a program that asks the user to enter a password. If the user enters the right password, the program should tell him that they are logged into the system. Otherwise, the program should ask them to re-enter the password. The user should get only 5 trials to enter the password, after which point the program should tell them that they are kicked off of the system, or they are kicked off the system. So this is going to be either a while loop or a for loop, whichever one you want. You can do it with whichever one you want. So you just assume a password. You get the assignment. So it's simple. So when do you want to submit your assignment? When do you want to submit your assignment?
Thursday.
Have you finished? Have you finished the previous one?
Yes.
Are you sure Thursday is not too far? Today is Friday. So you want to submit it next week Thursday? It's too far now. You wouldn't have
Wednesday.
had. No. Today is Friday, right? Okay,
God.
submit it by. Hmm, submit it by Wednesday. Wednesday
Thank you,
morning.
sir.
So I give you the whole of Tuesday. I give you the whole of Tuesday. I'm submitting it literally Tuesday midnight. So 0000 on Wednesday morning should be the deadline for your assignments to get to me. So you can send the assignments. I'll show you how you send the assignments so that you don't stress on that. All right now. So if you have any more questions, you can mail me, you can comment, you can say it on the Slack and tag me, whichever way you want to do it. Just ask your question. If you have a difficulty, if you made a discovery, whatever it is, let me know. All right, so we call it a day on that note. Thank you for your time.
Thanks so much.
Yes, and have a great day.